where you have two blocks connected by light string passing over a pulley. And we're told that this angle here is 32 degrees and the angle here is 61 degrees. And in the first part, we actually find the tension A, assuming that we have an acceleration going up. So if this acceleration is going up, the alpha here will be clockwise and negative, and we'll have an acceleration here going down the inclined plane. All right, so FTA so we'll have an FTA here, which will be equal and opposite to the FTA here. And we'll also have an FTB here, which will be equal and opposite to the FTB acting on the box on the lower end of the inclined plane. All right, so let's look at just box number 1 to find FTA. All right, so for box 1, and we're assuming that there is no friction on this inclined plane, it will have its gravity acting downwards. And it will have a normal force acting perpendicular to the inclined plane. And so we have to convert the mg into a component going along the y direction and a component going along the x direction. All right, so let's extend our axis. And we'll put mg on the side here. So there'll be a mg, a force of gravity for A acting along the y direction. All right, so FGA y, and a force of gravity of A G acting along the x direction, which will be pointing this way. All right. So since this is 32 degrees, the angle here will have to be 90 minus 32. So the angle in here will also be 32 degrees. So that tells us that the FGX is equal to mg sine of 32. And so since there's no acceleration in the y direction, Fn is equal to Fgy, which we'll probably not need in this problem, but we just have to write out anyway. And that would be mg cosine of 32 degrees. So for box A, we can look at the sum of the forces acting along the x direction, which would be the tension force going up, which is positive, and the FGX, which pulls it down the plane, which is mg sine of 32 degrees, and that is all equal to ma, and a is positive since it's going in the positive x direction. And fortunately, we're given the acceleration in this problem to be 1.4 meters per second square. So we can find FTA, which is equal to ma plus mg sine of 32 degrees. And we told that the mass of A is equal to 8 kilograms. All right, so putting the mass of A in this equation and the acceleration of 1.4 and the value for G, we find that FTA is equal to 52.75 newtons. All right, so the next part we have to find the FTB. And so in the same way, we have gravity acting downwards. And we'll have a y-axis acting going this way. So there'll be a y component of the gravitational force, and also an x component which goes down the inclined plane. And again, if this is 61 degrees, the angle here will have to be 61 degrees. So for B, the sum of the forces according to Newton's second law in the x direction will be equal to, so if we say this way is positive and that way is negative, FTB will be negative, and the FG along the x direction will be positive, and that will be MBG sine of 61. And the acceleration is in the positive direction, so we have a positive MA on the other side. So FTB will be equal to MBG sine 61 minus MB times the acceleration. So putting in the values for MB and G and the acceleration, we find that the FTB is equal to 71.7 newtons. All right, in the next part of the problem, we have to find the net torque acting on the pulley. All right, so we have our pulley, and it has one force here, FTA or FTB, and another force here, FTA, and it's accelerating alpha in the clockwise direction, so that's a negative acceleration, angular acceleration. All right. So remember that the net torque, apply Newton's second law, the net torque is equal to the moment of inertia times the angular acceleration. And so the net torque will be FTA times the radius. So this is clockwise. FTB times the radius is clockwise, so it should be, so FTA is counterclockwise, so it should be positive, and FTB is clockwise, so we provide a negative torque, so we have FTB here. And again, since the alpha here is in the clockwise direction, it has to have a negative sign. So the negative sign here will come out here, and so this part of the equation will also be negative. But we don't have a value of alpha, except that we know that alpha is equal to the linear acceleration divided by the radius. But in the first part of the problem, we just have to find this net torque, so we can just use this part of the equation here to find the net torque, given that the radius of the pulley is 0.15 meters. So we put in FTA from the last part and FTB from the last part, and we find that the net torque is equal to minus 2.85 Newton meter. And since we have to find the magnitude of the net torque, that would be just the positive value of this, which would be 2.85 Newton meters. All right, so the next part, we'll have to find the moment of inertia of the pulley. So we know that the net torque here in this part of the equation is equal to, all right, so that's right, minus I A over R. So we know what the radius is, we know what the acceleration is, and we can just rewrite this equation here to find the moment of inertia. And so we find the moment of inertia is equal to 0.305 kilograms meters square.